Welcome to my first Code Wars or Code Challenge problem solving video where I will try to solve and explain my steps or my workflow into solving some of these nice little uh, problems called katas in Code Wars. This one is a 6 KU. I think that's how it's pronounced. They have 8 levels here, 8 being the easiest, 1 being the most difficult. So this one will be classified as an easy to medium problem. All right, so let's start. Now, this problem I think is persistent bugger or booger, I'm not sure. Uh, and the description reads as write a function persistence that takes in a positive parameter num and returns its multiplicative persistence, which is the number of times you must multiply the digits in num until you reach a single digit. And there's some examples here. Persistence taking a value of 39 or num of 39 ends up being 3. You return a 3. Why? All right, so if we run this is 3 times 9 equals 27. And because 27 is a 2-digit number, you continue on to now 2 times 7, which is 14. 14 continues to be a 2-digit number, so 1 times 4 equals 4. And 4 only has 1 digit, so if we count the persistence here, we have 1, 2, and 3. And then they have another example here, 2 more examples. Persistence 999 ends up being 4. Why? Let's see. 9 times 9 times 9 equals 729. Okay, that ends up being a 3 digit. 7 times 2 times 9 equals 126, which also continue being a 3 digit. 1 times 2 times 6 equals 12, which ends up being a 2 digit. And then finally, 1 times 2 equals 2, which is a single digit. And that's where we end our program. And then there's one more, which is 4. And because 4 is already a 1-digit number, you return 0. All right, so looking at this, I see that we need some type of counter. We need to track how many times we're multiplying. So let's just create a new variable called counter. We'll make it a let because it's something we want to continue to add to. So here we have a counter 0. Perfect. And this is what we're going to ultimately end up returning as well. So if we run this program, we will probably pass one of the tests. Why? Because we're returning a 0. But this is not the way to solve this problem. But we already know that returning 0 passes one of our test cases. All right. So then we have a number, and we want to somehow split that number and then multiply that number, those digits, right? So let's try to just do one example. Let's see how we can multiply this. Let's just console log this. If we console log a num, let's see some examples here. 39, 4, 25, and 999. Cool. Let's turn that number into a string. JavaScript has a toString method we could use for that. Okay, so it might not look like a string, but this is now a string. We need to somehow split this number. So we could also use a split method, which is just split. And we need to pass in a string so that it knows to split. What is the parameter to split it by? All right, so we have 3 times 9. Cool. Now that we have the split number, how can we multiply? Let's assign this value into maybe something called digits. And let's make sure we put a semicolon at the end and let's iterate through digits. We'll use a nice classic for loop here, nothing fancy. Um, and we want to put the parameters that if we'll stop the for loop, or we'll go through the for loops by the length of the digits. Cool, and then we'll increment here. All right, and if we console log this here, what will we get? We'll get digits, and then we want to find out what we get here. Perfect, 3 and 9. 3 and 9. Let's create a new variable here for like our results, right? We like or maybe, yeah, let's create something like results, and we'll assign it to 1 for now. All right, so we want results to equal results times the digits here, and then I want to console log results and see what happens. 27, 4, 10, 7, 29. All right, so 27 was because of 39 being split into 3 and 9. So 3 times 9 equals 27. What's great about that is that we kind of know what to do with when we split something. But this doesn't necessarily solve the problem, because now that we have 27, we kind of have to redo this stuff again until we get to that single digit number. All right, so that makes me think of maybe a while loop, and the while loop will probably continue as our digits continues to be greater than 1. All right, so let's see here. Let's create a while loop here. While digits length is greater than 1, we will do something. And for now, I'm going to comment this off. Okay, so maybe, so something we want to do here also is, as we continue to go through this while loop, we want to increment our counter. And this is how we will solve how many times, or the persistence of each number. All right, and then here, what we want to do, same thing, we want to let result equals 1. And then we could just copy the stuff here. And we can uncomment this, and we could fix this code. All right, we'll delete this here. All right, this is looking a little cleaner. If we run this, we'll probably hit a infinite loop, because I am not updating this digits here. So if we test, results is not defined. Right, results here. Right, I think I just hit a infinite loop here, which means I broke the program. Why? Because this will never stop. After we get the final results, what we want to do is we want to do digits equal results dot to string, and then we resplit. All right, I think this should fix our issue here. Let's test. Perfect. And then let's try to attempt. This should now run it on big numbers. This worked. All right, so now to explain what's happening here again. We mentioned that we want a counter to keep track of how many times we're multiplying those numbers. we are splitting this digits, right? We are saying that a num we're taking an integer and we turn it into a string, and then we splitting that, right? So the example here will be 39 will turn into 39, which will turn into an array of 3 and 9. I think this is a nice little breakthrough of what we're doing here. All right, and then we're saying here, wow, the digits length is greater than 1, meaning while this array, right, has more than one element, we're going to continue this while loop. And then here I'm saying let results equals 1. This is just so that we can multiply the numbers easily. I don't want it to be a 0. If it's a 0, then it might not work, because something multiplied to 0 is always 0. All right, so here I'm just iterating through this digits elements, right? This digits array, and I am multiplying to results. So in the first one, if we run this through, the first one is 1 times 3 equals 3, and then we iterate again. Result was 3. So 3 times 9 equals 27, and then there's no more elements. So now here, 27 to string, which is 27, but just in a string, to split becomes 2 elements, 2 and 7 for digits, and we increment the counter. I guess here it doesn't really matter if the counter goes there or there. We just have to make sure that we increment persistence count, and then here we reset digits so that we can continue this operation. And then once we hit that single digit, this while loop ends, and we have our counter, so we just return a counter. Let's just attempt, and let's submit, and we are done. As you can see, there's other. What's a great thing about this, you could compare with other people what type of approach they took, and you will see some really clever approaches. You might see some really crazy approaches, and maybe some slow ones. Like for example, let's look at this one. All right, so instead of counter, they use times here. They converted the num to a string right away. They didn't split. So okay, they do it later. So while the num length is greater than 1, all right, so as you notice here, they didn't split. They didn't turn it into an array. In JavaScript, you could get the length of the string and almost operate like an array. So here, if the string was 39, so the length is more than 1. It's 2, because there's 2 items in that string. There's 2 characters in that string. All right, so here they did, while num length is greater than 1, they just incremented the counter right away, which is fine. And that's what I mentioned earlier. It doesn't matter where you put the counter as long as you can continue incrementing it. And then here, what they did is they kind of, all right, so they split the number, then they map. They split the number, which is a string at this point. Then they map and turn each item in that array into a number, which is pretty cool. And then they kind of iterate again and reduce it by multiplying those numbers to then convert it into a string. So this is what I mean by clevers. This is a really nice, clever solution. Is a one-liner. It might be difficult for a beginner to read. So what I like to do is try to do the long approach, and then do some of this like magic one-liner functional programming. This is another cool one. Let's see. they converted. All right, so they converted the number into a string using the JavaScript dollar notation, uh, which is not bad at all. This is pretty clever too. They then, if it's greater than uh, one plus the persistence. Oh, cool. They kind of did like a recursion function here. They are recalling this persistence over and over until they only get one. Apologies, zero, which is pretty cool. It's hard to read, so you need to know recursion for this one. Um, cool. But that's about it. If you are interested in learning more, I will be attempting to post more videos. This is my first one. Please leave a comment if you feel like you learned something, or if I messed up in any way. It will be super helpful. I really appreciate it. Thank you, and have a good one.